We've talked about addition and subtraction. In Lesson 3, let's talk about multiplying with scientific notation. So here's our first example. 3 times 10 to the 4th times 2 times 10 to the 5th. Before we get into it, let's consider multiplying two numbers with coefficients in the same base. Let's say I had something like 3a to the 4th times 4a to the 5th. Now, if you'll remember, this is really just two numbers being multiplied together. That's 3 times a to the 4th, right? We can group those together, times 4 times a to the 5th. And when you look at this, hopefully you're already picking up on the fact that these two things look very much like each other. Down here, we just had two constants, 3 and 4, and two exponents with the same base, a to the 4th and a to the 5th. Up here, we have the same thing, two constants, 3 and 2, and two exponents with the same base, 10 to the 4th and 10 to the 5th. So the process that we would use to solve this is the same that we would use to solve this. We would simply multiply the 3 and the 4, grouping those together, and then multiply the a to the 4th and a to the 5th, which means we would add our exponents, and that would give us 12a to the 9th. So let's use that same process to solve the rest of this problem, to evaluate the rest of our exponent. 3 times 2, multiplying our constants, 3 times 2 is going to give me 6. And then these two exponents with the same base, I'm going to multiply together, and that's going to give me 10 to the 4 plus 5 power. And I'm just multiplying those two things together. So that's going to give me 6 times 10 to the 9th. And that's pretty much all we're doing anytime we multiply with scientific notation. Now let's do a slightly more complicated example. In this case, once again, we have two constants multiplied by two exponents with the same base. In this case, we're going to multiply our exponents with their decimals. So 18.3 times 6.2. It's always easier to put the larger one on top. It doesn't matter whether your decimals are lined up at all. 2 times 3 is 6. 2 times 8 is 16. Carry the 1 for 366. Bring our 0 down. 6 times 3 is 18. Carry the 1. 6 times 8 is 48. Plus 1 is 49. 6 times 1 is 6. Plus the 4 we carried is 10. We'll add those together and we'll get 6, 14. Carry the 1. 13, carry the 1, and we deal with our decimals. So we have two numbers to the right of the decimal point. That means we'll put our decimal here, 113.46. And then we have to deal with our exponents. Well, that's going to be times 10 to the 4 plus 2, which is going to give us 113.46 times 10 to the 6th. But we're not done. Why not? Well, because we're not in proper scientific notation. In proper scientific notation, remember, we have to have one number to the decimal point, and then we can have our other significant digits times 10 to the whatever power. Over here, what we've got to do is move our decimal point 2 spaces to the left to get that. So we have 1.1346. But in order to do that, we have to increase our power on our 10. And that's going to give us 10 to the 8th. And remember why we do that is because up here, 113.46 times 10 to the 6th is 113. And then we move that decimal point 6 spaces, so we get 460,000 for 113,460,000. If we move this to the left, we have to increase that number so that we get the same number. This is, again, 1. And then we move the decimal 8 spaces, so we get 1, 1, 3, 4, 6, and 4 more zeros. And that's going to give us the proper number, 113,460,000. So this is our correct answer. One last example before we go. Same situation, two constants and two exponents with the same base. This time we have a negative exponent and a positive exponent. We're going to do the same thing. We're going to multiply our two constants, so 5 times 7 is 35. Then we're going to add our exponents, 10 to the negative 5 plus 10. That's going to give us 35 times 10 to the 5th, right? Because negative 5 plus 10 is 5. But we can't forget, got to make sure that we put our decimal back in the right place. In this case, we're going to have to move our decimal back one more space to give it proper scientific notation. That's going to give us 3.5. But in order to do that, again, we have to increase the number on our exponent. Because we're moving our decimal to the left, we have to increase the exponent. So we get 3.5 times 10 to the 6, and you're done.